Okay, thanks for coming, guys. Okay, so to start the class today, we're going to be working on this spell work. We've gone over before how to find the area of these different shapes, and today we're going to be learning how to find the area of a circle. So I thought it would be good for us to go over a rectangle, triangle, and a parallelogram. So you guys can start working on that for a minute. I'll give you like a minute or so to work on it by yourselves.
Okay, it's on a piece of paper. Do we need to put like the units next to it? Or the
No,
units
there
or-
aren't any units, so just numbers. Okay.
Okay.
Okay, it looks like you're both getting done. Let's go through this together. How did we find the area of this rectangle?
Times 7 times 3.
Yeah,
Times
length.
7 times 3.
Lengths times the weights.
Yeah, length and width. What's that?
21.
21, right. Good job. Okay, how about for this triangle? How did we do that? Since we didn't know the length of the whole bottom, what do we have to do?
We have to multiply the 2 times the 4 times the half, but then you multiply by 2 because there's 2 of the same halves.
Okay, so that's really good.
1/2 times.
So that's
That equals half of the triangle, right?
so that's 4, but we have to times by 2. So that's 8 because this is half of the triangle. That's good though, using that. How about this parallelogram? How could we break that up into other shapes in order to find the area?
It's 2 triangles.
It's 2 triangles.
And a square.
Can
rectangle.
Sean, do you want to come show me where that triangle was?
It's gonna like that.
Oh.
And then you have 4 pieces of triangle.
So what was your math? What did you do? Just write it out right here for me real quick.
So I divided this by 4, and I got 1 triangle, 4 times 2.5. And then that equals 10. Just like we're doing over here, 4 times 2, right?
Okay.
And then
Is that the what? Okay.
right, and so then you take
I have to take half of that.
right.
Yeah.
Equals 5, but there are 4 of them times 4 equals 20.
20.
Yeah? Okay.
What about you, Tom? How about you show me how you did it?
Okay.
It looks like you had another way.
Well, I didn't get the same answer. No, I don't know if it's the same thing or not. I didn't know what that distance was, but I knew that this was a square. And then if you take this piece right here and you put it on the other side of there, you make another perfect square. Which means this will be 10 and this will be 4. So technically you just have a square that's 10 by 4. So I just did 10 times 4.
Okay.
So I kind of cheated, I think. But I don't know if that's the right answer.
That's great. So Sean, you see kind of where you're wrong a little bit.
Yeah, 'cause I
down
didn't
here?
finish it.
Oh, you didn't.
No.
Well, also we can't really divide this by 4 because we don't have 4 even parts, right? Because if we divided it by, it's only hitting 2 of our triangles.
Right.
So that's where you went wrong. Okay, good. So we can see how we can like make other shapes in order to find the area. So today what we're going to be doing is we're going to be cutting out these circles. I have some scissors for you. Sure. You can work together on this. So you can just kind of cut off one, or you can cut off two if you want.
So start cutting?
Yeah, just cut them out as quick as you can.
All the pieces?
All the pieces.
Even the ones with like the dots and everything.
Mm-hmm. Yep.
Okay. So
And then
every little triangle.
we're gonna figure out if we can find the area of a triangle. So as Sean's cutting, let's kind of get some brainstorm ideas here. What do you guys think? How can we find the area of a circle by cutting it up into pieces?
Well, I'm sure you could like, when we move the shapes over there to like make it into a square. I'm trying to think, I don't know.
You taught us circumference.
We did.
That's
Sean,
right.
what is the circumference?
2 pi r.
2 pi r. Good job. So maybe that's something that we could use in finding the area, right? You guys have any ideas that you want to write down? You can draw them on your paper or here on the whiteboard.
I don't know.
So since what does pi represent exactly? I don't know if that's a good question or that's hard to answer.
Yeah.
I don't know.
Well, pi is
3.14?
yeah, well that's the number of pi. We have our circle. That's our radius.
Yeah.
As I remember correctly, we'll look that up, but I think pi, it kind of represents
The outside.
the outside portion.
It makes sense why you multiply 2 pi.
Mhm. Yeah.
Mm.
So it's, you remember when we did that circumference activity, how we were measuring around all of the different circular objects? They all had
That outside.
3.14.
Yeah.
There was a way that we could make it 3.14.
Mhm. So if we wanted to multiply the circumference, is there a way to make it sort of
Make it a rhombus.
a rhombus? Yeah, because then technically the circumference is on the outside. The width of it always is the radius.
Do we know the area of a rhombus?
Well, we did it.
Mm-hmm.
A parallelogram is this way.
A parallelogram,
Rhombus,
yeah.
That's right.
And since we can move, oh, this is wrong. I don't know like the exact equation, but I'm assuming that the whole idea behind the parallelogram, I don't know, so,
Parallelogram.
is that you could take one end of it and attach it to the other side, and you'll make a perfect rectangle. So maybe in this sense, since we already have the circumference outline on both sides, would you divide the circumference by 2? And then multiply this by
Well, because this
radius?
is the radius, and then this is half of the
Half the
circumference.
So is it the circumference times r divided by 2?
I don't know, it's because it's bumpy.
I'm hearing some good thinking here going on. Now our shape, because we cut out a circle, it might not be perfectly symmetrical, but using our knowledge of what we know about a circle and what we know about circumference, we'll be able to find the area. Well, let's look at this. So we have all the circumference on the edges,
Mm-hmm.
right? What do we have?
The
on the
radius.
sides?
Radius.
The radius on the outside.
Mhm.
So dealing with area, what could that be so far?
20
Circumference.
How would we write that out, like in a mathematical way?
2 pi r times an r.
2 pi r times. Oh, I'm sorry, we're stuck. Okay.
2 pi r times r. Yeah.
2 pi r times r. Does that simplify?
Yeah. 2
What's-
pi r squared.
2 pi r squared. So that's your final answer? That's the area?
No, because the circumference is laid out on both sides. So wouldn't you have to take half of the circumference? Because if we wanted to in the parallelogram, we'd be multiplying both of the lengths times the width, but we don't
So
want to
1
do
half
that.
2 pi r squared.
So it would be
So we have possibility of 2 pi r squared
or
or 1/2. 1/2.
times 2 pi r
That.
squared.
Or you could just do pi r squared.
Because they would cancel, I think is what you're thinking, right? Yeah.
Half
So
equals
just pi r
pi r
squared.
squared.
Wait a minute.
Wait.
Would the half equal the pi r squared?
No. It's just pi r
So
squared.
you
times
divide this by 2 because you want half of what the circumference is, right?
Maybe it would help, Tom, if you kind of drew what you guys had down here up here
Yeah.
and we're writing it out.
So it's like kind of all bumpy here.
Mm-hmm.
Then you got down and then bumpy again. Up again. And this is r. And this is
It's-
2.
It's 1/2 2 pi r.
Yeah. So it would, since all this is the circumference, this and this and this combined, you're going to take half of that. Half of 2 pi r squared. We'll take half of it, the 2's will cancel.
Right, so it's just pi
So
r squared.
one side will be pi r squared.
And the other side's pi r squared.
And so then you would just oh wait. Oh, it's 2 pi r. So it's not r squared.
Right.
Right. Sorry, my bad. So then you just multiply those together. And like you said, r times r, you get pi r squared. I think that's it.
Do you agree,
It's as close as
Sean?
I can get.
Yeah?
Yeah.
You guys did it. That was great. Isn't that so neat? That we can apply all that we learned before to be able to find the area of a circle.
It's kind of cool.
We used our previous knowledge.
You can just move the shapes.
Yeah, we just moved the shapes around. We cut them up. So our kind of look like this, right?
Uh-huh.
So for everybody else in the class, I'm gonna kind of go over it again. So we had our whole circumference, which was this bottom and this top.
Uh-huh.
So that was 2 pi r. And we knew that this, because it was a part of our circle, that was the radius, right? But since we're finding the area, we know that we only have to use one side times another side.
Uh-huh.
The length times the height. In order to find the area. So that would be half of 2 pi r times r. That cancels. So we have pi r times r to get pi r squared. Does anybody have any questions about how we did that?
No.
Or you star students.
You are great, Sean. Okay, so I want to talk for a little minute about how you guys decided to do that. What made you want to make it a parallelogram?
Because we've done it before.
Yeah. This shape was familiar when we saw it on when we put it on the board.
Why didn't you guys try and make a triangle or a rectangle like we had done?
Because that was the easiest way that they go together.
Yeah, just doing length times height and not having to like make a big triangle and then try to measure like different radius, like radius lengths,
Mhm.
height lengths.
Yeah.
Because here you just have one radius, and so all I have to do is multiply that one radius by whatever on the bottom.
Yeah, good job. After we struggled for a little bit, you know, we thought about things and we thought about what would be the best method for us, the easiest, and it led us to find the answer, to find the area of a circle, which is pi r squared.